The Global Positioning System, GPS, is a satellite-based navigation system that provides precise geolocation and time information to users worldwide. Originally developed by the United States Department of Defense for military applications, GPS has since been widely adopted for civilian use and has become indispensable across various industries, including transportation, telecommunications, emergency response, and geospatial sciences. This article offers an in-depth exploration of GPS, covering its history, technical principles, applications, limitations, and future advancements. Navigation systems. Before the advent of satellite navigation, various terrestrial-based positioning systems were used. The most notable predecessors of GPS include LORAN, long-range navigation, a hyperbolic radio navigation system developed during World War II, which used low-frequency radio signals to determine positions. Transit, the first operational satellite navigation system, introduced by the U.S. Navy in the 1960s. It relied on the Doppler effect to estimate locations, but suffered from limited accuracy and infrequent updates. 1.2. The birth of GPS. In the 1970s, the U.S. Department of Defense initiated the development of a satellite-based positioning system known as Navstar GPS. The first experimental satellite was launched in 1978, and by the mid-1990s, the system had achieved full operational capability with a constellation of 24 satellites. 1.3. Civilian accessibility. Originally restricted for military use, GPS became available for civilian applications in the 1980s. However, a policy known as Selective Availability, SA, deliberately degraded the accuracy of civilian signals. In 2000, SA was deactivated, significantly improving the precision of civilian GPS services. 2. How GPS works. 2.1. The GPS constellation. GPS operates with a constellation of at least 24 satellites, orbiting approximately 2,200 kilometers, 12,550 miles above Earth. These satellites are arranged in 6 orbital planes to ensure global coverage and continuous availability. 2.2. Trilateration in GPS positioning. GPS receivers determine their position through a method known as trilateration, which requires signals from at least 4 satellites. 1. Distance calculation. Each satellite broadcasts a signal containing its location and the precise time of transmission. The receiver calculates the distance to each satellite by measuring the signal's time delay. 2. Intersection of spheres. The calculated distance from each satellite forms a sphere. The intersection of these spheres determines the receiver's exact position.